In this video, I am looking at this sequence of numbers, 3, 6, 12, 24, and so on, and I'd like to find the general formula for this sequence. And so the first thing I do is ask myself whether or not it's arithmetic. Are we going up by adding the same amount each time? To go from 3 to 6, you'd be adding 3. To go from 6 to 12, you'd be adding 6. Okay, so we're not adding the same amount each time, which means it's not arithmetic. The next question to ask myself, is it geometric? And if it's geometric, then we'd be changing each time by multiplying by the same amount. To go from 3 to 6, you would multiply by 2. To go from 6 to 12, you would also multiply by 2. To go from 12 to 24, you would also multiply by 2. So then we can say that this is definitely a geometric sequence. And it's a geometric sequence where the common ratio, the amount that we're going up by each time via multiplication, is 2. Remember that the formula that we have for a geometric sequence, for its general formula, is that the nth term, term an, will be the first term, a1, multiplied by that common ratio to the power of n minus 1. And we know both parts. We know what the first term is. The first term happens to be 3, and the common ratio happens to be 2. So for our sequence, the formula for an should be 3 times 2 to the power of n minus 1. And of course, we should be able to double check to make sure that this formula gives us the terms of the sequence that we've seen. So for example, if I were to put in 4 for n, hopefully that this should give me 24 as an answer. And it does. If I were to put 4 in for n, I would have 2 to the power of 4 minus 1, or 2 to the power of 3, which is 2 times 2 times 2, or 8. And 8 times 3 does indeed give me 24. And I can check to see, does it give me the other terms in the sequence that we've seen so far. If I wanted to, I could have also made some predictions for future terms. If it doubles and doubles and doubles each time, then the fifth term should be 2 times 24, or 48, and we can check to see whether or not a5 is 48 via this formula. And it is. So I found then that the general formula for this particular sequence, 3 times 2 to the power of n minus 1.